Okay, today we're looking at writing equations of hyperbolas. So you're going to go ahead and want to copy down these problems. If you want to go ahead and pause that so you can get them written down, that's great. Or you can just kind of write while I talk. On this first example, we're given the vertices and we're given the foci. So the first thing we need to do is graph everything that we're given. So the first thing we'll do is we'll go in and graph these points. We're going to graph the point 8, negative 4. That's my vertex, so I'm going to put a fat dot. 8, positive 4. And then my foci are 8, negative 6, and 8, 6. Okay. Based on this, we can see that our center here would be at 8, 0. So we know that our center is 8, 0. We also know this is going to be a vertical hyperbola because my vertices are going up and down, so our y is going to come first. Our y will lead. So when we write our equation, it's always going to be fraction minus fraction equals 1. The tops are where my center go. The bottoms are where my distances, my vertical and my horizontal distance go. So we know that y is going to lead, and here's x. So my y value is 0. The y value of my center is 0, so it's just going to be y squared. The x value of my center is at 8, so we always change the signs. We'll have x minus 8 squared. Under y is the distance from the center up to your vertex. So since this distance here is 4, under y we're going to put a 16. So this is distance, center, up, and then we're going to square it. So then we'll square that number. Under x, this is distance from the center out to the sides. However, we don't know that. All we know is the foci. So we know our foci equation is c squared equals a squared plus b squared. So we can rearrange this, and in order to get b squared by itself, we'll subtract a squared. So we'll have b squared equals c squared minus a squared. This is still going to be the long distance squared minus the short distance squared. Okay, so our foci distance minus our vertex distance. So in this problem, our foci are 6 units away. So we're going to have 6 squared minus our vertex distance away, which is 4 squared. That'll equal b squared. So 36 minus 20 will equal b squared. So 16 equals b squared. That number is what goes under here. So our b squared is 16. That means that we're going to go left and right 4 in order to finish our graph. 1, 2, we'll pretend like 4 fits. 1, 2, 3, 4. And that way we can graph in our box, draw in our asymptotes, and then our hyperbola is going to open up because those are my vertices. And I remember that because I use nice and fat points, and that's also where my foci are. In order to give yourself some notes, we're going to go ahead and write over here to find missing b squared. We're going to say take center to focus squared minus center to vertex squared. Okay, again, we'll rewrite it as b squared equals c squared minus a squared. Just that way you have something special written out over there to help you find that missing b squared. The second example we're going to do, here it gives us the center, the vertex, and our asymptotes. So as usual, we want to start off by graphing this information. That's going to help us write our equation. So if we go ahead and draw in our graph, our center's at 0, 0. We have a vertex at negative 4, 0. So we'll use a fat dot because it's a vertex. Because my center is at 0, 0, I also know that I'll have one over here at 4, 0. Okay, those are my vertices. Then we have an asymptote that has y equals negative 3/4 x. So that means my asymptotes go up 3 over 4, which would be my corner, down 3, left 4, which would be my corner, and then negative 3/4, so down 3, right 4, and up 3, left 4. You notice those give me the corners of my box where I draw in my asymptotes. So you know if we were to draw in this box, we'd have a co-vertice here because it's got to go straight across like a rectangle. we'd also have a co-vertice down here because it's got to form that rectangle. So that's why I draw on the coordinates, the points of mine, before I actually draw on the asymptote. That way we can see where on our y-axis or where on that vertical axis we would find our co-vertices, which are going to give me my b squared value. So now we can draw on our asymptotes. Oops. We can go ahead and draw on the rest of our hyperbola. We know it comes out here from the sides because those are our vertices, our fat dots. So when we go to write our equation is always fraction minus fraction equals 1. The top is where my center goes. Because my vertices go out sideways, this is going to be a horizontal hyperbola, sorry, I keep messing that up, which means x leads. So my x term is going to lead. Since it's at 0, 0, we have x squared minus y squared. Under x is from the center right squared, so from my center to the right is 4 units, so that squared is 16. Under y is center up squared, so from my center up, because we know it has to fall in that same line, it's going to line up with the corners where my asymptotes go, we know that is 3 units up. So we're going to square that, and 9 will go under my y squared. Okay, so when it gives you the asymptotes, you want to plot the corners. That way you can determine where those co-vertices would be. Where does it actually cross the missing axis, so you can find that b value that that is not specifically given to you. However, once you draw the picture, it's a little bit easier to see. You can also notice that the vertical distance is your rise, the square root of that. So the square root of 9 is 3. Your horizontal distance, since here it's 4, the square root of that square root is 16. So they're going to match up with that, most specifically when you don't have a y-intercept. When you have a y-intercept, your slope, one's going to be positive, one's going to be negative, but they might have a different y-intercept. So you need to graph it and just kind of take your picture reference from there.